Hello, everyone. I hope you can hear me. This is episode number 6 of the series of intro demo making for the Amiga. With me, let me first unmute him. With
Check,
me,
check.
there is
Hello.
Ozzy. Can you talk, Ozzy?
Check, check. Hello, hello everyone.
Yeah.
I'm here. Can you hear me?
Are you far away from the microphone? You're far away now. I hear you far away.
No, I'm exactly at the same spot like before when we did the sound check.
Today we have another episode of the Amiga intro demo coding. I have my usual ritual to do. As always, I have to apologize to Ozzy. I did not advertise the stream. The reason being is I had to prepare some stuff for the game jam that we have, else I would have done it, and unfortunately I didn't. But next one, there will be an advert, don't worry. So let's start with the let's go to the uh, usual ritual. So as always, please subscribe and like our YouTube channel. It's the only way we know that we can share what we do. I remind you that under each video, it's always the same. That I have to repeat it because people still don't do it. Under each video, you get links to source code and to anything else that is related to the video. Besides that, but thank you. I will pass the message to Crane. Besides that, you can see that you get links to where, for example, you can download the source code. And as you can see, the tutorials of Ozzy are there. Okay, there's a directory with every episode. I mean, I have only done till episode 3 so far. So you get the source code per episode. I remind you also that I have a Phase 101 Facebook page where there is everything on it. And I have, it's my blog, basically, the Facebook page, nothing else. And the Phase 101 Facebook group. Plus the Commodore Dev Facebook group, which anything goes there that is related to Commodore. Besides that, if you want to reach me, the best way to reach me is on Discord. The links are in the upper right hand corner of this stream, but you also see a message from time to time with Linktree. If you click on that, you get all the links related to Phase 101. You can send me messages on Facebook. I'm not saying not to, but I take time to read them. I'm not always on Facebook. It's only when I release something. I also have a Telegram group. It's still in its initial, let's say, phase of this of it. It's some people just do not want to use neither Discord nor Facebook, so I just give them the option to go to Telegram. For those that want to support us and would like to see more, there is Patreon and Coffee. They are identical, and you will unlock 73 videos right now if you subscribe to one of them. That's basically it. However, we need to say congratulations to Ozzy. Let me jump. Browser. Yeah, it is okay, I think. we need to say congratulations to Ozzy. He came second in a demo competition, and this is his demo. Well done, Ozzy.
Yeah, second place.
Can you hear the sound?
I don't,
Yeah,
but I am not on Twitch.
I cannot hear it neither. That's the thing, and it's not muted, you see? Hold on. Sorry, I apologize, my fault. I need to start again then. Okay. By the way, thank you for the credits. For the greetings.
You are in the greetings, and I think Dario also is inside. And of course, there are some people in the credits as well.
Yeah, I am in the greeting.
Yeah, well deserved, I would say. I'm not hearing the music.
See,
I
it's
will-
difficult to hear you with the music. It's not fair. Pelicus is before me. It's not fair.
I don't remember the order, if it's alphabetical or not.
I'm joking.
And the bar is from Rangem, the red bar.
Yes, that
Because
I was going to ask you. That red bar sounds familiar.
Yeah, I copied.
Okay. That's it.
It's if it's okay for you, I'd like to talk a little bit about
Yes.
this demo.
Just give me 1 minute. I was going to ask you some questions. This is the GitHub location where the source code for this intro demo is. So you can all have a look at it. Ozzy made it public. So Also note that next week we'll be talking more about it. So we will have one session just dedicated to it in the next uh, episode. Anyway, all yours. You can talk about it as much as you like, my friend.
Okay, so I was thinking since you showed the demo, I'd like to say something not about from the technical point of view
Mm-hmm.
because it's pretty boring. It's just the story how this demo came out. Uh, because I think that it could be is interesting for someone maybe. So actually, this is not really a demo. This is what is called intro,
Mm-hmm.
and I my understanding is that intros are just a little demos. When I say little, I say little in terms of executable size.
Mm-hmm.
So in this competition, but in any other competition that are related to intros, usually they state a size limit of the executable, which usually is 64K, but there are other more size coded related parties that put some other limits, for example, 4K and 60K. And of course, you can't cheat streaming from the internet, of course. And so this was my first experience with some sort of size coding because, of course, the demo is 19 kilobytes. So I am well below the threshold of the maximum allowed limit, which is 64. But my goal was to stay under 16 kilobytes, and also I targeted an OCS platform, which is an Amiga 1000. And for me, it was a new experience because in my other production, I targeted an ECS Amiga. And when you target this type of machine, you know you have 1 megabyte of chip RAM, which is a lot. And maybe you can also add some fast RAM, so you don't have really big size constraints, relatively speaking. But this time, the target was an Amiga 1000, and the initial target was to use 265 kilobytes of chip RAM,
56.
and I failed all the way because the final size, executable size is the 19, and the chip RAM which is needed is 180 kilobytes, which could be good for a stock Amiga 1000, but you have also to remember that when you load the operating system, even if the workbench is not loaded, you have a bare minimum functionality, still eats some chip RAM. And this left you a little bit of chip RAM because, as you know, there is also this problem of fragmentation. For example, when you load the OS, there are some areas that could be used by the OS, and so this means that the whole block of memory not available is fragmented. So you have to adjust your hunks, and this is something that I don't usually pay attention when I do demo coding, because when you target, as I said, low higher spec Amigas, you don't pay attention. You just say, okay, this is the asset and put somewhere in RAM. I don't care. Uh, for me, the journey was very strange because since I had these very tight uh, constraints, it felt like I have to be very careful for each instruction. And at some point, I felt like a poet. Uh, and what I mean is, if you read a poem, they are usually quite short, they are not full stories, but still they transmit to the reader something, a concept. And in a poem, every word must be picked out very carefully because you don't, you have to just use the right word to express your feelings or to express what you want to express. And this is the same when you do this type of work. You have this huge instruction set from the Motorola, and you for each problem you have to try to solve it with less instruction as much as possible, or creating some redundancy, because if you create some patterns, the compressor will will try to do a good job and reduce the final size of the executable. So this was my first experience with the size coding. I'm not happy because I failed, and I failed mainly because the I didn't pick the right tools, in my opinion, because the music player, for example, it is a software which is called the Pretracker, and I think it's from a very well-known demo group, which is Abyss. I don't know how to pronounce it, but maybe my understanding is that this type of player is good for 64K productions or above. But when you go under a certain threshold, you must use some other tools because this demo, as I said, it's 19 kilobytes, and I think 12 kilobytes or even more are taken from the music, the player, and the assets. And the assets are very, very small because, as you can see, there are almost, there are tiles. So it's 16 by 16 tiles with 3 big planes. It's not a huge deal in terms of memory. And of course, the triangles are real-time calculated. So all the vertices, the rotations, the deformation, the shearing, the scaling, this is all done with what I explained in this channel in the last episodes. So it's just my routines that are at work and demonstrating that they are in some way working. And also the movements of the triangles, if you see closely, there is this sort of made up gravity, and this is also done with vectors and also applying a force with a vector to the mover object, which is a triangle. And of course, this is not a physics engine, it's not a accurate simulation, but it works for me. And what it matters most, it works for the Amiga because the calculations are very quick and simple. And as you can see, we have 5 triangles. It means you have 15 angles, 15 vertices, and at 50 hertz, you can calculate all the coordinates real time and draw and feel and do much of other stuff. If you have the debug version of this intro, you will also notice that there is still plenty of raster time available. So in theory, I could have added more triangles, maybe 6, 7, 8, probably also 9, I don't know. But the point is, I didn't want the scene to be so chaotic. For me, 5 was the right number. It was showing that the routines are fast, but the demo is not so complex and chaotic. So this is why I ended up with this. But after all, what I would like to say it is that it was my first experience and it was a very fun journey. I felt like a poet, an assembler poet. I don't know if there is, but that's it. For the people who doesn't know, there are a lot of demo parties throughout the whole world, and almost every week there is one. Of course, they are not all of them are Amiga related, and this party, when I won second place, is not 100% Amiga oriented. The competition is called Old School Intro Compo. This means that you have to um, do something for an old machine, but it could be Commodore 64, it could be PSP, PlayStation Portable, for example. It's considered old hardware. It could be, I don't know, there is a list of platforms that you can use. But what I see usually is that people tend to code this type of things on Commodore 64 and Amiga. Above Commodore 64, and the intro that won the competition was made on a Commodore 64. It was about Pac-Man going to heaven. A very nice intro, and well deserved the first place. But as I said, there are plenty of demo parties around the world. There is also a website which is demoparty.net, which is like this portal that lists all the events. And after that the demo party is done, usually all the production are published on demozoo or poet.net, and they usually are freely distributed and you can download for free. It's not commercial software usually. Yeah, for example, you see that these are the upcoming parties, and of course, as I said, not all of them are old school related. There are some that are focused on PC, other on Commodore 64, other it's more generalistic, but that's it. I picked the Flash Party, which is quite unusual because it's in Argentina. I don't know how to say it in English, Buenos Aires. And I have hard time following the event because of the time zone in Italy. I just picked this because when I finished my first demo, I want to publish, and I said, oh, let's see which is the next demo party, and it was Flash Party. So I sent my work, it was a Rodonea, the first time, and I enjoyed the party, and I continue. This is my third year participating and challenging. And for me, the votation it's fair. There are good entries, and the party is well organized. So I would say that if people, if your audience, maybe there is some developer which is more focused on demo or intros instead of gaming, participating in one of these events is good because, first of all, you get a motivation to do something good because you want to hand out something which is good, of course. You you have a time limit because, of course, there is a deadline and you have to give your work before a particular date. And of course, you get also positive feedback or negative if you did something stupid or if you didn't, your production was not well received. You understand what's wrong, where you did wrong. And most of all, if you participate, there is a good chance that you will be contacted by someone, which, for example, is striving to do production and just asking for help, or if you want to collaborate. For example, after my second participation, I was contacted by Resistance demo group, and they asked me to join, and so I did, and I learned a lot from them. So it's also a form of socialization, I would say. Of course, not everybody likes it. Maybe I know a lot of people that prefer to work alone on his own, but that's not my case. For me, demo party is a good showcase for me, for my abilities, and also to get some honest feedback. Uh, so that's why I do this, and I'm planning to participate maybe next year. I don't know if I have time, but yeah, this is what I would like to say about this intro. Don't know if there are some questions, because, or if I bother you with my story. I don't know.
No. But we are still going to do an episode on the demo, no?
Yes, if you want, I
Yeah.
can talk about the technical aspect of the demo. For example, how do I rotate the triangles,
Yeah.
and how, for example, if you recall, there are these spaceships
Yeah.
that travel across the screen, and there is a spaceship which is accelerating, and then it's braking and stopping at a particular point, and then accelerating again. There is another spaceship which is also traveling always at the same speed. So this is just vectors, and this is what I talked about last week, and what I'm going to talk about
Uh-huh.
today. And these are sprites. There are some concepts. For example, this little twister which comes out from the big spaceship. This is another trick I use. There are two sprites, and it's just plotting. It, it is built just plotting this cosine function inside these two sprites. So, and there is the music routine, of course. There is this color cycling in the sky, very basic, nothing fancy. So there are a lot of things that could be interesting for someone to discuss. I don't know. Maybe, of course, the code, it's very big, in the sense that there are a lot of files, and I can't discuss any of that. What I'd like to do is just to discuss the main aspect of
Sure.
this production, of how the triangles are blitted, how do I construct the shape and the borders, and how do I feel, what is the main concept behind. And I don't know, actually, because I didn't have a schedule yet, or
Yeah,
a list
sure,
of
sure, sure.
topics. But
Sure.
I can think next weekend about it.
Yeah. So let's jump to the development screen. So this is the first um, example for today. I'm going to run it. Um, well, I'm going to run
Can I
it.
stop you just a little bit?
Yeah, I'm just going to prepare so you
Because
can talk.
Okay, because I said Dockster in chat that said my first thoughts of the demo intro, Bob Jack, and the answer is yes. This is clearly stated in the README file,
Uh-huh.
GitHub, and also the title of the production is Bomb Triangles. It's a clear reference to Bomb Jack. what I'd like to point out is that the code is 100% by me, of course, and also the assets were done. They are inspired from Bombjack, of course, but I, let's say, hired a guy who knows how to draw, and he redraw all the data for me, of the assets. Especially the spaceship is very different from the one from Bombjack. What still is equal to the Bombjack first level is the gradient of the platform, because I liked it and because I copy the gradient. And the other thing that I still copied is the red bar by by RamJam, and all the other stuff, let's say it's original, it's not copied or ripped from other productions. But yes, because I just wanted to clarify this because I always quote the sources when I copy.
Yeah.
Because for me it's a shame to copy without quoting the original author, and this is something that shouldn't be done. You shouldn't do, even if there are no money involved in this type of competition. You don't get any revenue of this. The only prize that you get is a PDF document that states that you were awarded with the second place or first place or third place, and I make a picture out of it and hang on my wall here if I win, of course. But still, even if there are no money involved, I still want to quote every time what I used to, what inspired me, and what I really copy and paste.
Yeah.
And this time I copied and pasted the Fabio/RamJam code for the red bar. And other than that, it's all by me, I would say.
Hello,
Okay,
honey.
so
Hello. So that was the demo of Ozzy, and now we go and see the first example of Ozzy, which he will then explain later on.
okay.
So there you go. And if I press the right mouse button, they also move to.
Yeah, this is I just reused this little example because it's very similar to the last example of the previous episode. And I remember that someone in chat asked if I used the decimal
Yeah, it
point
was honey last time. Yeah,
notation.
yeah, it was honey. Yeah.
Yeah, and this is the version which is using the decimal part. It's a fixed point notation again because I don't use FPU. And the concept is that if you remember from last time, the squares were moving quite fast. And this is because if you accelerate each square of 1 pixel per frame, 1 pixel it's a very good amount of acceleration. So because you are in low res and you don't have so much pixel to work, and so you have to figure out something if you want to your scene to be less chaotic, for example. And this is the very same example. It's just using the last 6 digits as I usually do for decimal part. And I state, okay, the force is now 0 dot something instead of 1 pixel per second. So the gravity is not 1 pixel per second, is this time is much less, and the wind force is the same. It's it's under 1. It's between 1 and 0. So you get this, it's for me, it's a little, it's nice to see something like that. Of course, now they are still bouncing from left to right. This is because there is no friction. I didn't implement friction force. I just implemented the gravity and the wind, and that's it. So if you go to the code, you will see that it's the same exact example as before. What changes is when I declare the force, the external forces. So
you
maybe
need to tell me the
it's
lines,
good
no?
also. What can you repeat, please?
You have to tell me the lines, no? Like last time, where to go.
Yes, of course. Okay, you go to it's row 91.
Okay, yeah.
So the main concept here is you created two vectors again. The first one is the gravity vector, and the second one is the wind vector. And of course, the gravity is a force which is pulling your object towards the bottom of the screen. And so it means you have to increase the y-axis. And if you notice, there is d1, which is the y component of the vector, which is 8. But instead, it's not really 8 because the last digit, the last 6 digits are reserved for the decimal part. So you are defining a force which is, I don't know, I think it's 0.125. I don't know. I'm too tired to do the math, but you get to the point. And the wind, it's the same stuff. It's the wind is blowing to the right part of the screen, so it means you have to add a value on the x component of the vector, and in this case it's 2, but again this is not 2 as intended as an integer value, and this is 0.0 and something. And then at line 105, there is this initialization, I would say creation of the mover object. You notice that also here, each position is multiplied by 64. And this is what I usually do, just to state, okay, the last 6 digits are reserved for the decimal part. So the final result is that you have the integer part shifted to the left. And so the initial position is minus 20, and the initial position is minus 50, integer part, and 0 is the decimal part. And remember that I used negative numbers because at the very start of the before the game loop, I say translate to the center of the screen. So for me, the 0.0 coordinate is the center of the screen because it's how I like to think when I draw on the screen. And I think it's always something that it's more or less a standard, because I noticed that, for example, if you go to shader toy, there is always this concept that -1 is the left side of the screen and +1 is the right side. So it's not something that I'm not the only one using this type of concept. But again, I'm too much digression here. And the other assignments are just to describe how is the mover object. So the velocity is 0 for x and y at the beginning, and there is the color and the mass, which is not used at this stage. And then that's it, I would say. If you go a little bit, if you scroll down a little bit, you see that there are some other movers. There are or just two movers, and here is where at line 126 is where I translate to the center of the screen. So where I state that my point 00 is the center. And if you go to, for example, it's just to understand better what is going on, if you go to row 269, yeah, and this is the bouncing part when I say, okay, if you reach the right edge of the screen or the left edge, you have to negate, to invert the value of the velocity of the acceleration, but yes, of you say the velocity is negated, so you multiply by -1 and you simulate this bounce. And if you see here, I have to multiply each coordinate by 64, which is because again, I have to compare two numbers in fixed point notation, and for this reason, I have to put on the same scale each number, where the position of the object and the right border coordinates. Then the same for the Y position and all the others. You will find at line 260 and 74, there is the Y position edge. And at line 284, it's edge 2, which is the higher part. So if the roof of the screen, I would say. And that's it also for the others, the other position, like X position edge, and that's it. And what I'd like also to notice is when the mover show function and you go to line 312, and just scroll down a little bit. And this is the final normalization, because the draw routine is expecting numbers in integer format. So what I do is, okay, I strip the decimal part because you don't have to give sub-pixel information. You have just to state what is the coordinate. And so you shift to the right, you do the opposite. In this case, you shift to the right by 6. So all the decimal part is gone. And then you call the routine square. And the square routine will just, first it will draw the shape of the square, and then it will call automatically the filler routine, which again, in this case, it's not involving the blitter, it's just all done with the CPU. And the concept here is you first draw the left part, the left side of the square, and then you draw the right side of the square. And for each scan line, you just fill the inner part like the blitter would do. It's this very same concept, the very same algorithm, but it's implemented in CPU, because originally all this routine were intended for high-spec Amiga for vampires. And then I realized, okay, I can do the same stuff for older machine, and I rewrote the filler with the blitter using the RemJam/Fabio Chucci routines. So I would say that's all for this example.
Okay.
And we can
I can load the
just
other one,
show
no?
the second one.
Yeah.
Yeah.
So I will show the second one before. So I press the right mouse button and something else will happen.
Yeah, it's the same example as before, but this time what is different is the following. You notice that uh, the squares have different size, and I did that because I wanted to represent a different mass. So of course, this is my word, so the word that uh, my mind figure out. And in my mind, there is this concept that if the square is big, then the mass, the quantity of matter is much more. And if the mass is much more, you move slowly. And this is the concept. And this is also an example that it's about, I think, the second chapter of Nature of Code, uh, which is, if you recall from last time, I said that there is the force equal to acceleration time mass, and but the mass was not taken into account. I said, okay, let's pretend that the mass is always one, so every mover object is behaving like the other. And this time
Okay.
I wanted to implement the mass. Notice that, well, okay, I can show you the code, what changed in this example, and then I can talk about this concept in a little bit more depth. And what I'd like to show you is the mover apply force function
Mm-hmm.
at line 327. And this is really the only change if compared to the previous example. Of course, there are three movers and they have different values, but that's not the point. What I'd like to show is that if you recall from last time, this mover apply force function is meant to take an external force in the form of a 2D vector, for example, a gravity or a wind or a friction or whatever you want. You can build your own force, and this routine will apply the force to the mover object. This is the main concept. And last time, what I did, it was just, okay, I take the force, which is pointed by A3 address register, and I just do vector addition, so add to the vector. And for each force, for example, first I take the gravity force and I add the force to the mover object, so to the square. And then I call again this routine and I say, okay, apply the wind. And the wind vector is added to the mover object, the velocity, or to be honest, with the acceleration. And then you calculate the velocity, and from the velocity you get the final position of the object. And this routine does the same, but the difference is that you have to divide the force that, for example, the gravity or the wind by the mass of the object. And this is what I'm doing here at line 342. And this is something that also I want to point out, because I think it's not the proper way to do it, because when I built the mover object, I said, okay, the mass is just a little value. It could be 1, 2, 4, 5. So I just need a byte. And so I did. I declared the variable as a byte, assigned byte, because it was well beyond the limits. But then I realized, okay, if you declare as a byte, when you feed the data into the div function, the div M68, the M68 instruction, you have to provide a word, because the div instruction is expecting to divide a long word by a word. So for this reason, I had to extend. So as as often happens when you program in assembler, you have to choose between performances or memory. So this is just a very little problem. You have to say, okay, I waste an extra byte and declare the variable as a word, or I just say, okay, I will extend at line 343, I can also extend D0 to the word size and then do the math, the division. So from line 342 to line 346, I'm just creating a new vector. And why I'm creating a new vector? Because I need a copy of the force. I can't divide the gravity at this stage at the same location, because if you process the first square and you divide the gravity, then when the second square or the mover object is processed, you get half. And then another mover object gets in and you divide by 4. So this is not what I want. I want the gravity to be the same value for each mover object. So what I did is, okay, I just do a copy inside this the mover mass offset is the source, and then I store the result in mass result, and it's declared above at line 329. And then I created the 2D vector. Again, I want to point out this is not the fastest way to do it. It's, for me, it's just the more clear way to program and do not get crazy, because for me assembler can be very hard to read. If you start to optimize a lot, you do some strange things, and then you read again your code after a while and you say, oh, why I did this, I don't remember.
Yeah.
So my method at least is this. I try to write code as clean as I can with the function, and all the function is doing what it's meant to do. And then comes a second pass with the optimization, and inside you can do everything you want if you get better results, if you save memory, or if you save CPU cycles. And of course, it gets messy quite quickly, but for this example, I didn't want to optimize a lot.
I normally copy the same routine and make it comment it out and make it and then make the optimized version available, but I still leave the old one there just in case I need to remember what I'm doing.
Yeah. Another approach will be to very carefully comment what you are doing,
Yeah, I comment
but
always,
still,
but sometimes because even though you comment, you still uh, you still don't doesn't click, you know. So you will need the old way, the slow way of how the routine worked, so that you can remember exactly what you are optimizing, which part you are optimizing, and yeah,
but okay, you get the concept.
yes,
I'm just trying to do clean code here. I'm also lazy coding, but I think it makes sense to you.
No. It's of course everybody has got his preference, no?
Yeah, of course. So what's the most important line here is line 349. And this is a new macro. It's not really a routine, it's a macro, which is div to the vector static. And what it does, it performs division given two vectors. It performs division and puts the result in the argument that you give to the macro. In this case, is force result. The force result will hold what is in A0 divided by A1. Again, I want to stress particularly that divisions are very slow on all the 68,000. So use it carefully. What I try to do usually is to insert this type of divisions instruction when the blitter is doing something. And for me, it's the best way if you really need division and you can't use shift. But in this case, as I said, I'm not optimizing, so there is no blitter involved. You have to pay something in terms of CPU cycles. But the concept here is that you give the wind, for example, you give the gravity, and then you divide it by the mass, and you don't alter the original vectors. You just get this force result memory area, which is which holds the outcome of the division, and then you just perform again add to the vector. So the output of the division goes into the vector. So you apply the force to the mover object, and you will see in that both gravity and wind are affected by the gravity by the mass of the mover object, and the mass is initialized at the top, we saw before. If of course, if you put a very high number in the mass, there is a good chance that the square won't move because it's a too massive object to move and we stay still. And another important thing that I'd like to point out, and this is also what Daniel Schiffman pointed out in his book, is that if you recall, when you are at school, the science teacher told you probably this type of experiment from Galileo Galilei. He went to the Leaning Tower of Pisa. I don't know if you ever been there. It's a very strange tower which is leaning on one side. So he went on the top of the tower and he threw two objects of different masses, just to see if the physics theories from the old ancient Greek were right. And everybody was expecting that the massive object will fall before the less massive object. And he demonstrated that the calculation were not so correct because they didn't take into account the resistance of the force of the object to the air. So what Daniel suggested in his book is the gravity should not affect the mass, but the wind should affect the mass. Because if you have a very massive object and you have a wind blowing to one side, it should be harder to move the object. But still, if you go on the top of the tower and you throw two massive object, if they have the same air resistance, they should fall at the same time. And there are a lot of I remember someone did some experiment at school about this. I remember this fondly. So, but in my example, this is not taken into account. You will see that the very big square is moving slowly because the mass is a factor here. As you can see, we are dividing the mass, the gravity by the mass. And so this is the final result. This is my word. This is how I like the demo. And because, of course, this is not really a physics engine or whatsoever. It's just a simulation of my made-up gravity. So that's it.
Okay, so shall I go to example number 3?
Yes, please.
Yeah. Okay, perfect.
Velicus said that he used preprocessor directives, if zero and if, and this is something that GCC takes into account, but I don't know if Devpack is using it.
Yeah,
I
it
don't
does
know.
uses it. You can use that, but to be honest, I'm too old school. Before DefPack, there was Sika. Sika did not have these things.
VASM has some preprocessor
Yeah, it
directive,
has.
also
Yes, yes.
Devpack, but the syntax is quite different. And the main question here is I tried to
Look,
compile all my stuff on ASM1 because it's cool ASM1, and I didn't see any preprocessor directive in ASM1. I would like to discover if it's possible.
Dario,
Uh,
I have more than 50% of my sources in Sika, and I'm not joking. So, yeah.
yeah. Are there some preprocessors instruction like if zero and if in Seka or Sika?
No, didn't have. It's just no, didn't have. Uh, Imagine as in one without. It was all like having an editor with. You have to type, for example, E to edit, and it didn't have. Um, it was very strange how to use it. Let's put it not
Yeah,
easy, not easy. Imagine the editor of VI of Linux on uh, on the Amiga, but uh, in a much cut down version with less things. So yeah, it was very light, but it lacked lots of things.
yeah. The problem is that I would like to use ASM1 or every version or derivatives of ASM1, but for me, preprocessor directives are a deal breaker because I use it a lot. I always say, okay, if the processor is, for example, a vampire, then use this instruction, then otherwise use this or this. So, and I do this with the minus D at the compilation stage. And if ASM1 has not this feature, for me, it's a problem. But anyway, I will investigate on my own if it's possible to let's say, find a solution. And talking about this example, this is again the very same stuff, but I wanted to represent the vectors. This is the velocity vector, and this is scaled because the real vector is much shorter. I scaled about I think 8 times just to highlight the vector. So it's this line. If you see at the upper left corner, there is this strange line, and this is the direction which is the velocity vector scaled. And I just wanted to do this because I like to have a visual representation of what is happening. And not for every situation I use my unit testing framework. In this case, it makes sense for me to have a visual real-time representation. And as you can see, when the mover is going to the right, the arrow, even if it's not an arrow, it's pointing to the right, and if it's going down, it points down, and that's it. So it's just because I thought that maybe someone will be it will be not so 100% clear what is a vector and why I'm using it to as a representation of movements. So I thought that visualizing on the bit planes would be a good idea just to better understand what is going on here.
Mhm.
And that's it. If you want to
Oh,
see
hello.
the code,
Hello, Brother Bill. Hello. We are doing some demo coding using the framework of Ozzy. So, uh, yeah, welcome to the stream. So, I will go to the
yeah, just
code.
open the code
Yes,
just
yes,
to
yes.
work.
Yeah, this is the code that produces that sort of demo about vectors and masses and all that stuff. I'm explaining to Brother Bill, okay?
Yeah, good.
Uh-huh.
And please go to line 331.
Yeah, it's
300,
here.
okay.
Yeah.
And this is the routine which is responsible for drawing the square, which is called mover show function. Mover show function, and it's almost identical to the previous one of the other examples. The only difference is that after drawing a square, the square, and the square is drawn at line 320. After that,
Correct. Yeah.
I take the yes.
Mm-hmm.
After that, I take the upper left point, the vertex coordinates of the square, and I put them on data register D0 and D1 for the X and the Y components. Then again, I have to normalize with my shifting by 6 because I get rid of the decimal part of the number. And then I copy the integer part into D2 and D3, and I add the x velocity offset. I would say this is just an offset. I'm assuming that this mover x velocity offset A0 is the location where the vector of the mover object is stored. So I'm adding the value of the velocity for the x component and the y component into D4 and D5. And as I said before, since the vector was really short and it was barely noticeable, I took the liberty to multiply the values by 8 because I don't know, I think it's right. I divided by 8, so they were too much. I don't remember actually. ASR is dividing because you are shifting to the right. So you divide by 3. Okay, because they are okay. I'm multiplying actually because the this the we have a 6 digit, and then shifting by 3 makes 3 digits. So this is why we are multiplying actually, because they are multiplied by 64 and then I'm divided by 8. So this is the reason of the right shifting. And then I add to D2 and D3 the final result, and I call line draw routine. The line draw routine takes D0, D1, which is the upper left corner of the square or the move object, and D2 and D3 is the coordinate of the vector, the velocity vector, multiplied by 8. And then I draw the line, and that's it. And it was just a representation of the vector. It would be nicer also to do an arrow instead of a line, but it's extra work for the Amiga,
Yeah.
and I don't want to
So
to waste
shall I
much.
go to the next example?
Yeah, the next example is totally different,
Okay.
and I thought it would be nice just to change subject, to change topic, because too much vectors probably.
Okay, so let's show the next example. So this one,
This one needs, of course, a lot of explanation
yeah, I
because
was going to ask you.
we don't have forces anymore. We don't have gravity. We don't have wind. We just see three different movers wandering throughout the screen. But the main concept here is the following. When I was chatting with Dario a long time ago about texture mapping, I think, he told me a very interesting thing. He said, okay, if you want to do textures, you start from one point at a given, let's say you have a color, let's say red, and so you start with a red, you say point one is red color, and when you go to the right, the color goes toward another color, for example, green. So you have all these gradients in the middle. And I said, so this is something that I don't know if I'm wrong or not. I call this linear interpolation. And this is a concept that I remember I studied at the university a long time ago, but I don't remember nothing. And I said, okay, there is this map function inside the AProcessing, which does the following. It just converts a value from one range to another, which is something that reminds me a lot of this linear interpolation. And this is what I did. So just look at the red square. He's moving from x position 160 to the left boundary is minus 160. So it goes from the whole screen, I would say, because we are again in low res pal. So he is traveling, let's say, to 320 pixels. And I want the other movers to move accordingly in another scale. For example, the blue square, for the blue square, I said, okay, your range is minus 10 to 10.
Okay, I
So
got you
at
now.
each iteration, I'm converting the x position of the red square, and I put in another scale, which goes from minus 10 to 10. And the big square is the same concept, but I am converting it to a much wider range. I don't remember the numbers actually. I think it's I don't know. We will read
We can see it in the
later. But
code, no?
what?
We can see it in
Yeah,
the code.
we can see.
Yeah, yeah. Shall I go to the code?
Yes, please.
Okay, perfect. So we can start explaining the code now because this is what we were going to do. So,
Okay, so it was line 159, I think.
uh-huh. Yeah, here. These are the movers.
Um, yeah, I load the mover object into A0, and then I put into D0 the X position of the square, and this is our input value. So it's the number that we want to transform from one range to another.
Mm-hmm.
So this is the main concept. And then I put into D1 and D2 the original range. And then I say, okay, I want to get the very same number, but in the range of -10 to 10. And the mover 2 is, if I remember correctly, is the blue square at the top of the screen, and it's moving very slowly because, of course, we just gave him a little space to move. So the object will move between -10 and 10 when the reference square reached the right bound, which is a 160. The the blue box will be at +10, and then uh, when the red square is the left side of the screen, the blue box is at -10. So this routine for me could be useful every time you need, of course, to change the value from one range to another, but for me, it's very useful in a lot of scenarios. So for example, I thought maybe we want to go from color XXX to color YYY, and then we could use this map function, and it could be useful to someone. I don't know. For example, I just figure out that it would be cool to move these boxes, these squares proportionally to a reference square. So you can have multiple squares that moves at different speed without so much calculation, but they just move in harmony and one related to each other. The second mover at line 171 does the same, but I am scaling to the full width, so -160 and +160. So it's the very same concept. Again, in order to implement this map routine, I had to use both multiply and division. So if you don't want to use a pre-calculated table, keep in mind always that there are these type of instructions, and I didn't find out a neat way to do the same work without divs and mults. But again,
Actually,
and this
you,
is
you, you, you just said something which I wanted to ask you and I forgot. For your demo, okay? So, where you have the triangles, okay? Are these pre-calculated or not? So,
uh,
the
the vertex is not pre-calculated. It's all calculated in real time.
uh-huh,
But I have a sinus table and a
uh-huh.
cosinus. I don't know how to say in English.
Yeah,
There's
cosine,
two
yes.
tables, yes, are pre-calculated. What I have actually is just the sine table pre-calculated, and I derive the cosine in function to sine just to save space. because it's just a problem when you do size coding. You can pre-calculate this, so you don't write dc.w and all the cosine values. You just the calculate basis on the sine function, which is of course built manually with dc.w's.
Okay. For
But
those that,
again, other than that,
yeah, I was
no
going to say,
pre-calculation.
for those that have joined, didn't see this in the beginning of the stream, this is a demo that Ozzy did, and he came second in the Flash Party competition, demo competition. So, and he is using things that we are discussing here, okay? So he won this one, was it this weekend, no? You came second this weekend,
Yes,
no?
it was Sunday,
Yeah,
just Sunday.
this Sunday. Yeah. So back to the code.
And another thing that I want to say about this demo, if you notice the sky color is changing from one color to another.
Mm-hmm.
And guess how I did that? I used a custom version of my map function. And before the intro starts, I built a table using this map routine, and this table holds all the values of the gradient values in order to go from purple to blue. And this is another example of what I call linear interpolation. But again, I don't know if I'm right or not, if there is the right term. I just
I
say,
think Dario told you that you are right. You are using the right terms. So I think you are
okay,
right.
so
Yeah,
sorry,
you
but
see,
I was
he just
very bad at
replied.
math.
He just replied. You are right.
So, and this is, I think, the only irrelevant part of this example. And the good news is I don't have other stuff
Yeah.
to bother you.
So, so for today we finished the all episodes, not all all examples that we had for today. I'm going to run the demo again, or show the demo again, from the beginning this time, given that I won't have more issues with Twitch. And let's also listen to the music. It has big, the start of it is big in Japan, no?
Big in Japan, the music from Alphaville.
Yes, yes.
The music is by Maze, which is a
Yes, I
very
know.
famous.
But it
I
starts like
didn't.
big in Japan.
I didn't thought about that.
It's OCS production, not AGA production. OCS rules, yes. Oops. Let's do this again. So guys, thank you very much. Bye bye.